In this video, we are going to discuss the problem split the array in three equal sum subarrays. So the problem basically says that we'll be given an array and we have to determine if the array can be split into three consecutive parts such that the sum of all the three parts are equal. So basically suppose that if we have got an array like this. So the question is asking that if we have got an array, can we divide the array into three parts such that if this is index I, this is index j, so the sum of all the elements from the index 0 till the index I, then the sum of all the elements from the index I plus 1 till j, sum of all the elements from the index 0 till index I, sum of all the elements from 0 till I is equal to sum of all the array elements from the index I plus 1 till the jth index. Okay, and after that this particular sum is equal to the sum of all the elements from the index j plus 1 till the last element of the array. So the question is asking that if it is possible to divide the array into three equal subarrays such that they have got equal sum, then we need to return the indexes I and j. If it is not possible, then we need to return -1, -1. So we need to decide one thing, that when are we not going to have a subarray which is when are we not going to have three subarrays such that they have equal sum. So suppose if the array is given to us and the sum of the whole array is basically, let's say, 14. If the sum of the whole array is 14, can I divide that array into three equal parts? No, because if I do what? If I do 14 by 3, then I'll get decimal values. Then I'll get something in double. So I cannot divide the array into equal parts. So for dividing the array into equal parts, the sum should be divisible by 3. If the sum should be divisible by 3, if the sum is not divisible by 3, in such a case the answer will not be possible here. So this is one thing that we need to be very clear with. Okay, so firstly we'll find the sum of the array and we'll check that if the sum is not divisible by 3 completely, then the answer is not possible. If the sum is divisible by 3, then we'll try to find the segments. Okay, so since we already know that if we have got an array, so the indexes I and j are is what we are expecting here. So you can observe here that if let's say this is the index I, this is the index j. So we have been told that the sum of all the elements from the index 0 till index I, so sum of all the elements from the 0th index till the ith index should be equal to sum of all the elements from the I plus 1th index till the jth index, and this should be equal to sum of all the elements from the j plus 1th element till the last element of the array. Okay, so how can we do this? We can basically run two loops in order to achieve this, because firstly we can start a I loop, and you can understand one thing, that if we have an array, so the I index is going like we are having the first subarray from 0 till I. Okay, then the other elements are from I plus 1 till j and j plus 1 till the end. So the I can only go till the third last element, because the I is from the sum of all the elements from 0 till I is the first subarray. So after the first subarray, the second subarray and third subarray should also exist. So second subarray should be given at least one element and third subarray should be given at least one element. So my I needs to go till n minus 3 only. It cannot go beyond this, because I want to have the other two subarrays to have at least one element. Okay, that is why my I can go till this point only. So what I can do here is, I can basically another thing is that if we have this array, so my j can go till which index? J can go till n minus 2 only, that is the second last index. Why my j can go till the second last index only? The reason being because if my j is standing, if my j index is standing here, right? So the thing is that if my j index is at n minus 2, so I need to do another partition from j plus 1 till the end. So for the third partition, at least one element should be available. So that is why my j can go till the second last element only. Okay, now what will happen here is you'll basically iterate and you will say that you'll start your loop. I starts from 0, then I is lesser than equal to n minus 3 here, then you will do I plus plus. Okay, then after that you will run another loop j. So j will be starting from where? It will be one step ahead of I. So j will be starting from I plus 1 till j is less than equal to n minus 2, as we have discussed. Okay, then after that we'll do a j plus plus. Now after we have got our I and j loop sorted, then the sum one will be what? The sum of the first subarray will be basically you will be passing what? 0 comma I. So it will take out this function will take out the sum of all the elements from the 0th index till the ith index. Then s2 will be what? It will be the sum of all the elements from the I plus 1th index till the jth index. And sum 3 will be what? The sum of the third subarray will be sum of all the elements from the j plus 1th index till the last element of the array. Okay, now if the sum 1, sum 2 and sum 3 are equal, then we'll return the I and the j index. That is what we have been asked. Because if we find a subarray such that if we find three subarrays such that the sum from the index 0 till I is same as sum of all the elements from I plus 1 till j is same as sum of all the elements from j plus 1 till the end, then we need to return the indexes I and j, otherwise we need to return -1 -1. So you can see here that since we are taking three loops, why three loops? Because first loop is for the variable I, second is for variable j, and third loop we are taking while calculating the sum from 0 till I plus 1 till j, and j plus 1 till n minus 1. So the variable for the loop, the function for calculating the sum from 0th index till the ith index, or I plus 1 till j, in general this would take order of n time as well. So that is why the overall complexity right now is n cube, which is very high. So we have to reduce this complexity. Can we do it better? Yes. We can basically apply a linear approach, and we can still do the question by applying some logic here. So what we can do is we can simply say that if we have 1 3, and then we have got what, we have got 4, and then we have got 0 and 7. If we have got this particular array here, so what can I do here? You can observe that if I have got this array, so we have got the index 0, index 1, then index 2, then index 3, and then index 4. Okay, so if this is the array that I have here, so what will happen is, firstly, when I'm going to start off, so like I do know my total sum here, so total sum is 12. So this is this can be divided into three equal subarrays. I know this. Now sum by 3 is how much? Sum by 3 is 4. So every subarray, all the three subarrays will have the sum as 4. So whenever I reach the sum 4, I'll break my subarray there. Okay, I'll partition my subarray there. So initially I'll be at this particular index. Now my current sum will be what? My current sum is 1, which is not equal to the sum by 3. So I'll ask my pointer to move forward. Now I'll be at this particular element here. So far I have iterated through two elements, and now the sum is equal to 4. So if the current sum is equal to total sum by 3, in such a case I can say that yes, this much subarray can be broken. So I'll, in the resultant, I'll put the index 1, that yes, this is the ith index where I'm breaking. Now after that we'll move our element forward, and before doing that we'll make our current as 0, current sum as 0. Now when I add this particular element, so the sum becomes 4. So this means that this can be broken into another subarray here, okay, which is having the sum equal to the total sum by 3. So now this particular index can be put inside the result, okay. And then after this, like you can observe that still we have got indexes remaining, okay. The I value is less than n minus 1. I is less than the last index of the array. So this means that we still have got elements remaining in the array. So you can see here that the resultant array size is how much? The resultant array size now is 2. So this means that we have put the I and the j index, and we still have elements remaining in the array, in the original array. So this means that we have done two partitions, and third partition is also possible, which will have the equal sum. So that is why we should return the indexes I and j that is stored in the result. Okay, if this is not possible, then we'll return -1. So let's try and do this. So what we'll do here is, firstly we'll declare a variable sum. So sum will be initially equal to what? Sum will be initially equal to nothing but 0. Then after that we'll iterate. So like before iterating, we can simply say that we'll take n is equal to what? Arr dot size here, okay. And after this, what we'll do here is we'll say that int I will start from 0, I is lesser than n, then we'll do I plus plus. Okay, then after that we'll do what? We'll write sum plus is equal to what? Arr of I. So we'll take the sum of the ith element here. Then after this, what we'll do is we'll check that if the sum is not divisible by 3, if the sum modulo 3 is not equal to 0, in such a case we'll do what? We'll return -1 comma -1 here, okay. Now after that, what will happen here is, once we are done with this much part, so we need to declare a resultant list here. So let's say we'll declare a resultant list here, okay. Now after that we'll iterate. So we need a current sum variable which is equal to, let's say, 0. Now after that, what we'll do is we'll iterate. So we'll say that for int I starts from 0, I is lesser than what? N. Then we'll do I plus plus. Okay, then after that we'll do what? Current sum plus is equal to arr of I. Okay, then if the current sum is equal to the total sum by 3, so this means that I can do one subarray partition here. So in this case, in the resultant answer, I'll push this particular index, that this is the index where I can do a partition. So I'll push this particular index, and then I can mark my current sum equal to what? Equal to 0. Then after that, what I need to do is I need to check that if the resultant dot size is equal to 2. So if the resultant size is 2, so this means that if I have done two partitions already, and my I is less than n minus 1, as I told you already. So if two partitions are done, and for the third partition I still have elements, so third partition will definitely be possible, as you can see in the sample test case also. So we'll return this result here, which is consisting of the indexes I and j. Otherwise, if it is not possible, then we'll update the result as -1 comma -1, and then we can simply return this particular result here. Okay, so this is how we can write the code. You can see that it is linear because the approach just uses the prefix sum concept here. Okay, so let's just remove some syntax errors here and let's submit this again. So it is compiling currently. Let's see what happens. It is working fine on the sample test case. Let's submit this code to check if it is getting accepted or not. It should get accepted here. And you can see that our code is clearly getting accepted. So I hope that you have understood the logic here clearly. Now, if you'll see the time complexity for our code, so it'll be how much? It'll be order of n because we are linearly iterating throughout the array. Space complexity would be how much? It would be basically order of 1 because we are not taking any extra space. We are just declaring a resultant array which is of 2 size, which is constant in nature. Now, this problem previously has been asked in companies like Facebook, and it has also been asked in Microsoft. So I hope that you have understood the logic for this kind of problem. Okay, it is basically nothing but extension of prefix sum concept. So if you have any doubts, you can mention them in the comments if you understood this clearly. So make sure that you write understood in the chat. Thank you for watching this video and keep coding, guys.